So I'm going to talk about how and why to get into radiology research. This is my disclosure slide, which I was asked to put in. Okay, so I'm going to talk about why you might want to do radiological research, when you should think about doing it, what you might want to research, and how you go about doing it. So why do we want people to do research in radiology? Well, it's needed. It's very, very seriously needed. So this is a report that was commissioned several years ago now. It's published in March 2005. This is the Walport report. So this was done prior to something called MMC, Modernising Medical Careers. And this was a very wide-ranging report that looked into all aspects of across the whole of medicine, training researchers of the future. And in that, they did identify that there were certain specialties that were in particular need of academic reinvigoration because the amount of research that was being done in those specialties was actually declining. And one of those that was identified was radiology. And consistently since that point, radiology has been flagged as a specialty that needs more research in the UK in particular. So it is definitely needed. And we've seen some of the figures about this from the prior speaker. So look how much more imaging is happening in the UK. Huge quantities of imaging is going up year on year, mainly CT, MRI, these complex cross-sectional modalities. Someone needs to be looking at how do these modalities actually, how should they be employed in clinical practice? What difference do they make? Are they actually benefiting our patients? Do they have any downsides? Someone should be researching all of this. So there's a huge core of work that can be done, and also massive data sets that are ready to be examined to see the significance. There's some interesting technology coming to the market. So this is a whole body MRI, and it's been done on what we've heard about already, a PET MRI scanner. So there's on this side, this image here is using a tracer that shows you how much glucose is being used by the body. And tumours tend to use up a lot of glucose, so they show up in that fiery red-yellow colour. On the other side is a whole body MRI using a technique that shows how much the water in cells can diffuse, diffusion-weighted imaging, showing a similar thing, and we might want to compare those two techniques, see which is better, and so on and so forth. But nobody knows which is better. No one really knows how to deploy this test yet. Someone needs to research it and see how it should be best used in clinical practice. And research is great fun. It's a very interesting part of my job. It's certainly as interesting, I find, as the clinical side. It's a different kind of problem. Usually it's protracted. It's over a long period. We have what seems to be a simple question, and then you find out that actually that's underpinned by another question. And you answer that, and then there's another question, and the whole thing starts to unravel, and you have to trace the entire ball of wool, so to speak. It is very, very good fun, and it's enduring. So it's something that you can do for a very prolonged period and get a lot of satisfaction from. As well as being fun, it's also exciting. I think the two, you hopefully agree, the two are slightly different. There's something different about the excitement of getting new data or using a new technique or feeling that you're on the cutting edge of a particular area. So we've seen, I've already talked a little bit about PET MRI, so we've got an example of PET MRI here. There's other newer imaging techniques, hyperpolarized MRI, that's just being installed in various sites across the UK, Cambridge, UCL, Manchester, Oxford, etc. This is a technique called photoacoustic imaging, so that's an entirely new imaging technique based on using laser light to cause tissue to emit ultrasound. There's dynamic imaging techniques like dynamic MRI to show motion, quantitation of motion using ultrasound. All of these techniques are going to be coming to clinical practice within the next 5 to 10 years, and it's interesting to be at the forefront of working out how they can be used. It's interesting. So not only do you get to use those new techniques, you get to know the answers before anyone else. When the data set that you've been requesting from your statistician, or the data that you've collected from your research project finally hits your desk, you get to open up the virtual envelope usually in a big Excel spreadsheet or similar, and you can find out what the answer actually is, and you'll be the first to know that. And that is very interesting. It's like, you know, you get the gossip ahead of everybody else. If you do a lot of research and it goes well, you get to travel. So these are some, these are the locations that, just the European locations that I've been to in the past 5 years through research. And you get to see lots of parts of the world that you probably wouldn't otherwise visit. You know, normally I probably wouldn't have gone to Istanbul down at the bottom there. I probably wouldn't have gone to Lisbon, and actually Lisbon was beautiful. So, you know, sometimes these places are really nice. This is the Champalimaud Institute in Lisbon, out on the coast. Absolutely, you know, it's this guy was a benefactor who left €500 million to create this institute for researching the unknown. It's absolutely gorgeous. You know, there's the hotel opposite. So you get opportunities to see nice parts of the world. Why else do you research? Well, you accumulate expertise very rapidly. So this is one of the radiology special interest groups, Royal College of Radiology Special Interest Group. This is the BUZGAR committee, the British Society of Gastrointestinal and Abdominal Radiology committee. And if you're a researcher, then you become recognised as an expert in your field relatively quickly, and then you have the opportunity to join these committees and potentially influence the way that care is delivered. It probably makes you, often it makes you a better radiologist. Certainly I believe that the areas that I've researched, I've become better clinically because of that. This is a study, a very famous study of an area that I'm interested in, which is CT coronography, a technique for looking for cancers and polyps in the bowel using CT scanning. And in this study, they took a whole load of radiologists and they asked them to interpret a whole load of scans. They gave them a test, essentially. And only the top 15 radiologists of the 20 that they invited were allowed to participate in the study because they really wanted CT coronography to come out and looking good. So all of these radiologists know exactly how good they are at interpreting that examination. And not only that, they get feedback. You get feedback on the cases you've interpreted. In clinical practice, you don't always reliably get feedback on what you've got right or wrong. And even if you do get feedback, you're never 100% certain that that feedback is actually correct. If the surgeon takes the patient to theatre and says, oh, you know, couldn't find the perforation, then you don't know for sure that they just didn't look in the correct spot. In research, usually there's a very robust answer to each radiological question. So you get good feedback and you improve your skills because of that. You can, as well as getting clinical expertise, you can also have influence on national or international policy. So this is a paper that I wrote during my PhD about CT coronography, we've heard of that already, about how it was used in the screening programme in England. And as a result, the bowel cancer screening programme guidelines now incorporate some of those findings. So a national programme has been altered on the basis of work that we did in our centre, which is very gratifying. You feel like you're making a difference to a large number of patients. Similarly, this is another piece of work we did looking at CT coronography again, part of my PhD, incorporated into the pan-European guidelines about how to deploy the test. So you can have an influence beyond just your region, your area, your patients that you're seeing that day. It can influence medical practice more generally. It may do, it may not. It's a very flexible career. Research is a very flexible career, usually. So you largely decide your own schedule lots of the times. If you don't want to have research meetings that day, you don't have to have research meetings that day. No one in the university is checking that I'm at my university desk, making sure that I'm writing that paper or grading that, that attachment, that report, doing my marking the students' assignments. As long as I do it, and I do it by the deadline, they're pretty relaxed about it. So if I want to go and watch my daughter at her sports day, or my son's Easter parade at nursery, it's okay. I can duck out for a few hours to go and do that. I'll catch up. I'll write the paper at the weekend, or I'll mark the work that evening. It's very flexible. It's got longevity. The career is likely to have longevity. So we've heard some of these threats already. Outsourcing, AI, So outsourcing, I think this was felt of more of a threat perhaps a few years ago than now. I get the impression the tide is turning a little bit against outsourcing. People have tried it. They thought that you could have a radiologist or anywhere in the world sitting in a field with their computer interpreting the test. And actually, the real value of radiology is having a radiologist, boots on the ground in the hospital for dialogue with the clinicians, as well as doing the reports. But a proportion of the work will be outsourced. No one's going to outsource the research. Where the UK has a very strong academic sector, and radiological research is strong in the UK. So it's unlikely that that's going to be outsourced. What about AI? I think AI is a threat. DeepMind is based in London, and they have collaborated with various institutions in London, Royal Free, UCL, and I'm not personally involved, but from what I've heard, their technology is extremely impressive, and we will see AI doing a proportion of traditional radiological interpretive tasks shortly. But is that a major problem? Well, who knows, but we already have computers that are able to interpret radiological tests to a degree. There's something called CAD, computer-assisted detection, which is used routinely in a variety of settings: mammography interpretation, CT coronography interpretation, looking for lung nodules. So we already engage with computers already, and I think we'll just engage with AI in the same way. But that's a potential threat. Not particularly, though, if you're a researcher, because AI is not going to take the research away from you. In fact, it's a big opportunity. Someone has to research, is the AI doing as good a job as the radiologist? What incremental benefit is it having? What are the downsides? What are the costs? How do we deploy it in clinical practice? So it's actually a big opportunity for research rather than a threat. And longevity, you have to think about, I know it's very difficult now, I certainly didn't think about this when I was a medical student, because I wanted to be an interventional radiologist, not an academic radiologist. But there's very few emergencies in research radiology. No one's going to phone you up at night saying, I really need that last p-value on the data set. So before I went to medical school, ER was very popular, and everyone wanted to be like George Clooney, Doug Ross, the glamorous paediatrician saving lives in the middle of the night. You don't want to do that when you're 40 and you've already had 5 sleepless nights because your kids have been keeping you awake all night. So just think about that. Research is you can do it for a long time, and you're unlikely to burn out because of the stress. Why else do people do research? Because it looks good on their CV. I think that's the commonest reason that clinicians do research in the UK, because they want a CV point. But it's a terrible reason. If that's the only reason that you're thinking about doing research, just to make your CV look better, then think again. Just do something small. Do a small project just to fill in the little box. Just something that will let you reliably answer the question: what's the difference between research and audit, or research, audit, and service valuation? If you're only doing it to make your CV a bit better, then don't dedicate too much time to it. Just make sure it's good enough. You'd be better off spending your time elsewhere on something you actually want to do, because your enthusiasm will show when you do it in something else that you're more interested in. So learn some new clinical skills, get on a management course, try and get involved with some management, administer a junior doctor's rota when you're F1, F2. Do some quality improvement. That will be much more beneficial to you than doing a bit of research that you did just as a box-ticking exercise because you felt you had to. Okay, so there's loads of good reasons for doing research, I think. Obviously I'm biased, but there are lots of good reasons for doing research. So the question is then, when should you do it? When should you think about doing it? So this is the basic radiological training structure, which I'm sure you all know about. So typically people now will do foundation training for 2 years, and then they'll either go into another specialty, core medical, core surgical, sometimes pediatrics, sometimes anaesthetics and acute, but usually core medical, core surgical. They might do that for a year or 2, but the majority of people go straight into radiology from foundation, and then they will spend 5 years or so. So the standard radiological training prior to CCT is 5 years, which is split into 3 years of core training and 2 years of higher training. And you have exams along the way, which is split into Part 1, 2A and 2B. And you can often lengthen that training, so you might do an extra year at the end of your higher training, sometimes called a fellowship in a particular area. So you might do that in gastrointestinal imaging or neuroimaging or something. And if you're an interventional radiologist, you're going to be an interventional radiologist. You usually do 1 or 2 years of additional training at the end before you complete. Sometimes people will go abroad for a final year. It varies. But there is an opportunity for you to slot in some research at any point along that pathway. Slightly separate to that, there is an entirely, well, not entirely discrete, but there's a different pathway, which is an integrated academic training path. So this is for people who think from a very early stage that they might be interested in an academic career, or at least finding out more about academic medicine. And so these are not specific for radiology. There are so-called academic clinical fellows in different specialties, but radiology, you can do academic training in radiology. So as part of that, you may do an academic foundation year. You may do some research before you even finish qualifying, so before you qualified, so you may do an integrated BSc. Some of you may have already done that in a radiology subject. You could do a PhD while you're at medical school, a combined MD-PhD program, an academic foundation year, as I've said. If you then have an academic clinical fellowship, which is as a radiologist, you could then do some academic work during your first few years of core radiological training. And the different centres and different training schemes will organise how their ACFs do that research differently. You might do 1 day a week, or you might block it all up into a 3-month block, split it up and so forth. And that's for negotiation when you're in the post. But usually, what's the expectation, or the commonest thing that happens, is that people will do some research during that academic post to build a case or build some initial data to then do a longer postgraduate qualification, either an MD, which is usually a 2-year undertaking, or 3-year PhD. They'll do that during their radiological training and then come back and then finish off their clinical training. I think the important thing is that you don't need to commit to a fully blown academic research career at your stage. There is absolutely no mandate to do that, and I didn't do that, and I'll show you in a sec. Many of my colleagues who are now academics did not do that either. You don't need to decide now. You can do shorter projects just to get a feel for what you think radiological research might be like. So you can do them during an attachment as an undergraduate. Try and do something during an SSC or whatever they're called in your medical school, a student selection component. Integrated BScs if they're offered. Some places will allow you to do MScs or MPhils for a year. So do all of those things. Try and get involved with those things before you necessarily commit. So here are some examples. So when did these are the investigators in my institution, so at the UCL Centre for Medical Imaging. So this is Shonit Punwani. He's a reader, so he's about on the verge of becoming a professor. And when did he do his PhD? He did it before he even went to medical school, so he did it in MR Physics. So Steve Hagen, he's the head of the centre, and he did it during his FRCR, so relatively far along in his radiological training. So this is Stewart Taylor, another one of the professors, and he did it after his FRCR, so even further along. And this is me, and I did it after my CCT, so right at the very end. So you can actually do your research pretty much any time. You don't need to commit to a research career before you start thinking about it. Some people worry that doing a PhD delays their career, delays them from getting on. They just want to get, they've been training long enough, medical school's long enough, the training process is long enough. Do I really want to delay it? Well, you've got to bear it in context of the whole of your career. A consultant career is very long, and a PhD is only 3 years. Realistically, MDs the expectation is they're completed in 2 years. And one of those years, you could do some clinical work as well. So often, at least 6 months, and sometimes a year will be recognised towards your training. Same for a PhD. So if you just draw out the length of your life from 0 years to retirement, which is all the way over here, for you guys I put it at 70 years, because I expect that's what it will be. you can see the difference between the top one where you don't do a PhD and the bottom one where you do a PhD is very, very small. And actually, that's assuming the worst. That's 3 years for PhD additional training. It might only be 2. So it's a small additional length of time. So I wouldn't be worried about the fact that it's delaying you being a consultant. There's nothing that great about being a consultant, so you can delay it for an extra couple of years. Okay, so what should you research? And actually, I don't think the topic is that critical to your subsequent career focus, because it's going to evolve. So if you look at the topics of research that people do earlier in their career, their first few papers and then their subsequent career, they're often very, very different. You know, the first paper that I wrote was a case report about related to vascular surgery, or the radiological manifestation of something that was relevant for vascular surgery. So completely unrelated to what I do now. The important thing is that you get good quality general research skills. If you're seriously interested about doing more research, then the general skills are more important. And that's, when I say general skills, that's anything, whether it's basic science, how to do PCR, or pipette things correctly. I don't know anything about basic science, or whether it's clinical research about details of trial design, statistics, how to analyze diagnostic tests and studies. So those general skills will be transferable. And your interests are going to change, technology changes, and what you do will be very dependent on where you're based and the expertise available in your centre. So how do you go about getting good at doing research or getting involved in research? This is Nick Faldo. And Nick Faldo was a very good golfer as a young man, and early in his career. He was a very, very talented youngster. But he got to a point where he was one of the top golfers in Europe, and then he was on the verge of winning one of the major trophies. There are 4 major trophies in golf, and he was on the verge of winning one. But as he got towards the finish line, he sort of collapsed under pressure, and his swing fell apart. So everything went off in the wrong direction, and he lost the tournament. So what he did was he didn't sulk about it. He went to go and see this bloke, David Ledbetter, who was a golf coach, quite a famous golf coach. But he really made his career on the back of rebuilding Nick Faldo's swing, teaching him how to play in a different way. And then Faldo went on to become world #1 and win 6 majors. So what's the point? What's the lesson in that? It's that if you want to get good at something, you have to get guidance from someone. Doesn't matter how talented you are, you still need your equivalent of Yoda to sort of draw that out of you, to improve your talent, and really make you as good a researcher as you can be. So you need someone who can guide you. So how do you find those people? Well, the Royal College's website has got a section dedicated to academic radiology, and has all of these sub-parts, as you can see, including grants and awards for undergraduates. And on that, they have a research map. So it's just a Google Maps thing with various pins dropped into it to where the centres are. But each of those is clickable, so you can look at your area and you can click the relevant bit, and it will bring up a little mini profile of all the academic radiologists in that particular area. It's not completely, it's not 100% complete. There are, I'm sure, other academic radiologists that aren't listed, but the majority of people are on there, and that's a good place to look if you're looking for contacts. So this is my mentor, my Yoda figure. You can see he's very supportive. He sent that to me as soon as he got his new MacBook. This is Steve Halligan. Just pointing out that his arrived many weeks before mine. And he's the person that I turned to when I was thinking about how do I go about learning how to do academic radiology. So how do you know whether or not you found the right person? Well, you can Google them, of course. So that's what everyone does now, isn't it? You look at you look up the person that you're potentially interested in, who you think might be able to help you get where you want to go. So you should look at their track record and look at what they've done with their previous students. If you're seriously thinking about doing some research, find out what the people who did research with them previously have done. Not only that, if you can, get in touch with those people, email them, find out what they thought. What's he like to work with? You can also see what they've published. What are they? What kind of research do they do? Is it successful? Is it influential? Is it the kind of thing that you're interested in? How are they funded? Where are they getting their research funding from? Are they someone who's pulling in large grants from external funding bodies, from government funding bodies, competitive grants? Who do they collaborate with? Do they collaborate with high quality individuals? And word of mouth. Probably the most important thing is that you have to be able to get on with this person, particularly if you're going to spend a reasonable length of time working with them. If you're thinking of doing a higher degree with them, for example, then you have to be able to get on with them, because otherwise it's not really going to work out very well. And also, in practical terms, where are they based? It is possible to move, but that usually comes later in a career when you've decided that you're definitely going to be focused on doing research on a particular thing. You can't easily move across the country earlier in your career, certainly as an undergraduate. Okay, so what did I find when I looked into my potential mentor, Steve Hagen? So who was he collaborating with? Well, he's collaborating with Wendy King, who is an extremely eminent epidemiologist. She ran one of the largest randomised trials. They randomised over 170,000 patients. So serious, big deal. He was collaborating with Doug Altman, who is a statistician who has published the most highly cited paper ever in The Lancet. And he was working with Julieta Patnick, who was the director of NHS cancer screening programs. So he's working with high-level, big names. What was he publishing? He was publishing papers like this in The Lancet, so high-quality publications. And then what had happened to his prior fellows? Well, he'd had Stewart Taylor, who at that time had become a professor of radiology. He had Shomik Punwani, who had become a reader in radiology, and Vicky Go, who was also a professor of radiology. So his prior fellows had obviously gone on to do the kind of thing that I wanted to do. So that felt like the perfect kind of mentor for me. So if you want to do high quality research and you want to do it as a career, you probably need to find someone who can help guide you. Of course, it doesn't count for anything. It doesn't matter how fantastic their CV is if they're not prepared to help you and they're disorganized, useless, they don't respond to any of your emails, if they're the nutty professor. So that's why it's important to speak to people about what these people are like that you may be working with. This is the kind of feedback that you get from someone who's really engaged and really wants to help you and wants you to improve. So this is the first paper that I ever sent to Steve when I was his PhD student. And you can see he spent a huge amount of time going through it. And he's also altered, the first annotation there is 3:05. And then the last annotation, this is just on one page. The last annotation is at 4:29. So he spent an hour and a half just going through that bit of text in really fine detail, changing almost all of it, actually. But changing it for a reason, and all of those little comments and notes, he explained what was going on. And this is what you need from a real research mentor. They will really show you how to do it. And if they're not prepared to make the time for it, then just think, is this the kind of person that necessarily I want to spend my time with? So ask around, use the website of the university, of the medical school, look at things online, and approach the team directly, approach the research team directly. Now, I've talked a lot about doing a PhD, MD, PhD, so on. Just to reiterate the point, you don't need to overcommit at this stage. You can you just need to dip your toe as an undergraduate. It's more as a foundation year, or even once you're into radiology training, that you probably would think more seriously about it. But there's no harm in considering it even at this early stage, because you need to be setting the wheels in motion already. So it makes sense to start small and see if you like it or not. So you should see if the potential group that you're interested in, the academic group, do they help students? Have they taken students on before? Do they offer a BSc? Can you do an academic taster week? Can you do an academic attachment? approach the radiologist and co-author a case report. Maybe help gather some data for a poster, presentation, audit. It may get, it may get you a presentation at a radiological congress. And if you do decide to do a high degree, there are options: 1 year MPhil, 2 year MD, 3 year PhD. So you don't have to go from nothing to 3 years. These are the two of the students that we've had previously. The one on the left, from Belgium, actually, she did a 4-week attachment, got a conference paper out of it, and as co-author on a full paper. This is Sofika de Jong, so she's from Amsterdam, and she is doing a PhD, and she comes periodically and collaborates and has a conference paper and so on. So it doesn't mean you don't have to do the whole thing. Just in 4 weeks you can get a lot out of it. So to summarise, think about why you might want to do some research. If it's just for a line on your CV, then just get the line on the CV and do something else. If you want to spend a long time, or if you want to seriously think about doing a research career, then you may want to do something slightly longer. Test the waters, use your SSC, try and write a case report, do some posters or a presentation. If you enjoy that, then consider taking it further. And research careers are very rewarding, as I mentioned at the start. It's hard work, but it's worth it. And if you're going to do it as a career, you'll need some help, but it is out there if you look for it. Okay, thank you very much.
Thank you, Andrew. Any questions for Dr. Any questions for Andrew? Anybody? Have any of you managed to engage with research projects with your radiology departments? Some of you are nodding.
Nods, that's good.
Yeah, that's always encouraging. Was it difficult to arrange, or was it difficult to get into that? Did you find it challenging? No. Okay, some of you are nodding the other way, which is good too. So I'm not sure. But that's sometimes the difficulty, isn't it? Knowing how to find the right contact and how to find the right person to engage with and the right sort of project. I think Andrew's given you a few tips and hints, hopefully, of how to go about doing that. Is that research map up to date?
Yeah, more or less.
Yeah.
Yeah.
So that's a very nice.
Being continually updated. So I think the research map is a good place to start. The other thing is that you can always get in touch with the radiologists at the clinical radiologists at the hospital, and they'll often know who the academics are in their institution and can put you in touch.
Yeah, and some of the things, Andrew, your presentation that chimed with me, one of it is about trying to maybe get involved in a quality improvement project. If researchers, at your stage, that's actually a very useful way of dipping your toes in the water. Right. It's not genuine research, but actually sometimes makes a bigger immediate impact on what we do in our departments than the more highbrow research projects, which may be difficult to get into at your stage sometimes. The other thing that chimed with me was how relaxed you guys are with your academic lives. Nobody knows where you are, we can't get hold of you, and it's great. And the complete opposite is going to be our third speaker, who has just come from an emergency reporting session, hot-footed it, to speak to you. Thank you, Andrew.
No problem, thank you.